Hello HMS modelers. I'm Emily Moe with the U.S. Army Corps of Engineers St. Paul District. In this video, I'll provide an overview of various calibration metrics and tools within HEC-HMS. We'll discuss how to set computation points within HMS, go over how to access summary tables and calibration metrics, as well as an introduction to zonal calibration using slider bars and parameter tables. Let's start by talking about computation points within HMS. Why might using computation points be helpful to you? Where should these points be set? And how do you set them? How are computation points helpful to an HMS modeler? Well, computation points create element groups that include all subbasins and elements between computation points. The first handy computation point feature is that it enables fast and easy parameter table filtering. For example, heading to Parameters, Loss, Deficit and Constant brings up the deficit and constant parameter table. Filtering by computation point and selecting the point of interest shows just those subbasins within that computation point group. This is helpful for viewing and comparing nearby parameter values and can even be useful for calibration, which we'll touch on a bit later. Another great feature of computation points is the ability to compute to point. By right-clicking on a computation point and selecting Compute to Point, HMS will only recompute the elements upstream of that computation point, instead of recomputing the entire model. This can save a lot of time during calibration, particularly if you're working in a large watershed. Where should computation points be set? They can be set at any junction. However, gauge locations are a great place to use computation points, since you'll be adjusting and rerunning the model frequently during calibration at these locations. Setting computation points at other key locations, such as tributary junctions or areas where watershed features change rapidly, may also be useful. So how do you actually set a computation point? It's as simple as right-clicking on the intended junction element and selecting Select Computation Point. Once the computation point has been set, the junction icon will change to have a red background. This symbolizes that this junction is now set as a computation point, as shown here. Moving on, let's talk a little about summary tables and metrics that are available within HEC-HMS. We'll look at where they're located, what useful information they have, and how you can use that information. Where are the HMS summary tables located? Summary tables can be found at every junction element within HMS by right-clicking on the junction element, selecting View Results, and then Summary Table. What's included within the summary tables? Every summary table provides information about the simulation that you're running, such as the start and end date, which components the simulation is using, and the summary tables also always summarize the computed timing and magnitude of the peak discharge as well as the overall modeled event volume, which can be displayed in inches or acre-feet when English units are selected, as shown here. Another great summary table feature is that if you have observed flow data linked to that junction, HMS will also summarize the same metrics from the observed data. And HMS will also compute several goodness of fit statistics comparing the computed and the observed data for you. How can you use the summary table information during your calibration? The summary statistics provide a quantitative assessment of how well the model is reflecting the observed event. The suggested performance metrics table shown here by Moriazi can be referenced to quantify the calibration's goodness of fit. For example, this location has a Nash-Sutcliffe efficiency value of 0.888, which falls into the very good category. Therefore, the model would be considered quantitatively well fit to the observed data at this location. And HMS computed all of these metrics for us. Summary tables are also very useful for comparing other modeled versus observed event characteristics, such as timing, volume, and magnitude. This is useful when setting and tracking calibration goals, which we'll talk more about in the calibration strategies video. Next, we'll touch on zonal calibration. I'll mention 2 ways to calibrate HMS parameters by zone, including using the HMS slider bars feature, as well as by groups within the parameter tables. The first great approach to zonal calibration is using the slider bar calibration option. Elements, parameters, and ranges must first be set up to enable slider bar use. To access the slider bar feature, right-click on a computation point junction and select Calibration Aids. The slider bar calibration editor dialog box will open. The sliders are set up to reflect the calibrated range of each parameter, with the option to include custom plots to track calibration progress. Selecting Compute with each slider change will recompute the model and update the associated plots each time the slider bar is adjusted. The recomputation process is typically fairly quick for a nearly real-time cause and effect update as parameters are adjusted. The prep work to set up the ranges for the slider bar parameters can be time-consuming, but using them in real time is efficient with rapid recomputation as parameters are adjusted. Having the predefined ranges is also useful for ensuring adjustments stay within a reasonable range for each parameter. Another approach to zonal calibration is adjusting multiple elements at once by viewing the parameters by group in the parameter summary tables. For example, here we're viewing the loss parameters for the Martin computation point in this basin. Multiple subbasin parameters can be set or scaled all at once by highlighting the parameter, right-clicking, and selecting Fill. The Table Fill Options dialog will then pop up. From here, the initial parameters can be adjusted all at once. Adjusting parameters within the parameter tables by group is particularly useful when working in a large watershed. The slider bar dialog for 10 or more or even 100 or more subbasins can get a little overwhelming. Focusing on one computation point group at a time within the parameter tables and being able to scale and adjust multiple parameters in multiple subbasins all at once can be very efficient when tackling larger watersheds. Let's wrap up with some key takeaways. We've learned that setting computation points enables element grouping, the compute to point feature, and the use of slider bars and sorting by computation point groups within the parameter tables. The HMS summary tables are located at each junction and provide us with the model results at that location, as well as with valuable calibration metrics. Zonal calibration can be approached by using the slider bars or by sorting by groups within the parameter tables. Utilizing either of these options can improve the overall efficiency of your model calibration.